Okay, in this problem we're asked to find the sine of this angle, and they've given us a diagram, and the diagram shows it shows a angle that has made 1, 2, a little more than 2¼ rotations. So we don't really care about how many times it makes a rotation, but all we really want to focus in on is the denominator. And so every time we make a full rotation, if we split it up into pi over 6, which is the same thing as 30 degrees, when we get to 6 pi over 6, that would be the equivalent of making a trip from 0 to 180 degrees. So if we make another 6, it would make 1 full revolution. So if you add 6 more to that, every time you get 12 pi over 6, you made a full 1 revolution or 1 rotation. So we have 29. So if we make another revolution, we have a total of 24 over 6 pi. And we actually have how many pi left? 29 minus 24 gives me 5 pi over 6. So let me erase all this scratch work over here. So our 5 pi over 6 tells me that we end up over here in the second quadrant. And remember, in our little all students take calculus, ASTC, it tells us that in the quadrant 1, all 6 of the trigonometric identities are going to be positive. Over in quadrant 2, only sine and also cosecant are positive. So we know right away that our answers will be positive. So all we have to ask ourselves is, what's the denominator? Well, it's pi over 6. So if you use your hand trick, using the left hand, and you bend your ring finger, that's pi over 6. And sine is the square root of your lower fingers. So what's left below your ring finger? Only 1. So it's the square root of 1 over 2, which of course equals 1/2. And once again, since it's over in quadrant 2, the y value is positive. So the sine of this ridiculous 29 pi over 6 is equal to 1/2. And of course, we could verify that with a calculator. Just to double check ourselves, we go to mode, make sure we're in radians, and then type in sine of 29 pi divided by 6, and we get 0.5, or half. Okay. So it's helpful to see a picture of this, but we'll try one that doesn't have a picture in another video.